right, guys. So one part of equilibrium is you will see those equilibrium graphs that I had mentioned, looking at how the concentration changes over time and when it reaches equilibrium. So you're going to go through this graphing equilibrium activity that has 4 different kind of equilibrium scenarios that you're dealing with. I want to walk through the graph of the first one. That way you can look at how to proceed for the following graphs. So looking at experiment A, it says a chemist was studying the decomposition of methanol at a high temperature. She placed 1 mole of methanol into a 5-liter flask and allowed it to decompose for 30 minutes at a high temperature. After 20 minutes, the concentration of methanol had fallen to 0.05 molar, where it remained for the remainder of the experiment. And it gives us the formula of methanol in that double the reversible reaction with carbon monoxide and hydrogen. And it wants us to sketch a concentration versus time. Pay attention to what type of graph it tells you. But sketch a concentration versus time graph that would reflect the data from the experiment above. Show how the concentrations of all 3 species in the reaction would have changed over the 30-minute interval. So she placed 1 mole in a 5-liter flask. It wants us to graph concentration, so we need to figure out what is that concentration. So 1 mole over 5 liters is a 0.2, and I'm going to go to 2 sig figs based off of that. So that's a 0.2 molar methanol. So that is our starting point that we have. And you kind of need to figure out what your scale would be. I'm going to go by 0.05s. So I'm going to start at 0. This is 0.05, 0.10, 0.15, 0.20, 0.25, and 0.30. And you can have a different scale, but make sure that it's spread out enough where you're going to be able to see the lines. So it's telling us that methanol starts at 0.20. So I'm going to make blue methanol. It tells us after 20 minutes, the concentration of methanol is 0.050. So on the bottom, we need time. And I'm going to write it down below because I don't have a lot of room. So let's say that we break this into 5-minute increments because it says we're doing this over 30 minutes. So there's 5, 10, 15, 20, 25, 30, and 35. So at 20 minutes, methanol is now at 0.05. So it would be here. And it says that continues through the rest of the experiment. So we're going to notice that this is going to be kind of a sloped line and then level off after the 20 minutes. That is just the methanol. Notice that the question wants us to show the concentrations of all 3 species. So we're going to have to look at what is carbon monoxide doing and what is hydrogen doing. I'm going to do carbon monoxide. I'll do in red. Now, she did not initially put in carbon monoxide in there, so we're starting off with 0 carbon monoxide. And here's where your mole ratio is coming in. In the reaction, there was 1 mole of methanol and 1 mole of carbon monoxide. So these are going to change at the same rate. So methanol went down by 0.15 over the course of that 20 minutes. So carbon monoxide is going to go up by 0.15 in the course of those 20 minutes. So at 20 minutes, that's where we kind of hit that equilibrium. So the line for carbon monoxide should look something like that. Just kind of a mirror image of the methanol because they changed by the same amount. But let's look at hydrogen. Hydrogen has a coefficient of 2. So that means that hydrogen is going to change twice as much as the carbon monoxide or methanol. So yet again, it's a product. She did not add it at the beginning. So that is starting at 0. And I'm going to represent hydrogen with green so you can see it. So we said that carbon monoxide went up by 0.15. Well, hydrogen should go up by twice that much. So hydrogen would go up by 0.3 and still reach equilibrium at that same point in time. So this has a much higher slope. Excuse my drawing. So that's kind of what the graph would look like for these. So feel free to use that as your graph for the first part, and that will help you answer some of the corresponding questions. It may ask you to write the equilibrium expression, which is just what would the formula be without any numbers plugged in. It might ask you to find equilibrium constant, which is where you would plug in the numbers. So utilize that using all of the other experiments. Feel free to confer with your group if needed, but this is something that you should be able to do on your own if necessary.